In this video, I'd like to look at some more advanced word problems with the Pythagorean theorem. So, in this problem, a flagpole broke in a storm. 7 meters are still sticking straight out of the ground where it snapped, but the remaining piece has hinged over and touches the ground at a point 24 meters away horizontally. So, how tall was the flagpole before it broke? So let's draw a picture of this to try and get an idea of what exactly is going on. So we have this flagpole that broke, and we're told 7 meters are sticking straight out of the ground. So we at least have a 7 meter piece that is coming straight up. And where it's snapped, the remaining piece hinged over and touches the ground 24 meters away horizontally. So we don't know the length of the pole that goes from the snap corner to the ground, but what we do know is the horizontal distance away from where it originally stood. So this is going to be 24 meters, and like I mentioned, we don't know this length here, but we need to figure out how tall the flagpole was before it broke. So imagine the flagpole standing straight up, we need to figure out that total length. And basically what you can imagine is that where it's snapped, if you rotate this piece back up, we could find the total length of that flagpole. So it would essentially be this piece that's still sticking up plus this piece here. So that would be the total length of that flagpole. So we definitely need to figure out this missing side here. So let's just call this x. And we're dealing with the Pythagorean theorem. So remember that we would have a squared plus b squared is equal to c squared if we have some right triangle where the two legs of the triangle are a and b, doesn't matter which is which. And the hypotenuse, the length across from the right angle, that is just c. That's the long side of the triangle. So to use this relationship, we just need to match up what A, B, and C are. So the legs, it doesn't really matter. And we do have a right angle here because the flagpole was sticking straight out of the ground and this is the ground. So that would be at a right angle. So this could be A, this could be B, or you can switch those if you want. And the long side, that has to be C since that's across from the right angle. So plugging everything into our formula, we have that a squared, that's 7 squared, plus 24 squared is equal to c squared, which we called x, so we have x squared. And 7 times 7, that is 49. And 24 times 24, that is 576. So adding 49 and 576 together, we get 625. And now we just need to take a square root of each side. Now, the square root of 625, this is actually a perfect square. In fact, this is 25. So we found this missing length, and by the way, this is in meters. So we now know that this hinged over part, this is 25 meters long, but we need to find the total length of the flagpole. So remember when it was fully standing, we had this piece that was 7 meters out of the ground, but if we rotate up this fallen piece so that it was standing again, this would be the 25-meter piece. So the total length of the flagpole would be 25 plus 7. So that would be 32 meters in length.